Hello. Yeah, good evening, all of you. My voice is clear to all of you. Hello. Yeah, so my voice is clear to all of you. Now you can unmute yourself. Hello.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Fine.
Yes, sir.
So, good evening again. So today we are going to start our that is called the workshop. Basically, this workshop we are going to do for our, you can say, the revision and clearing the concept of building a structure, okay, in a combined way. Because see, there is like lots of things that you have learned throughout the training, and there are like mismatch. Okay, every time you are learning, some candidates get confused that why we are doing this one and why we are adopting this, why we are doing. So to solve that kind of problem, we are going to do this 40-hour workshop. The hour of estimation is 40. Okay, it may be changed. Okay, but right now we have 40-hour plan, and it's a start today, and it will end on like 30th of November. So basically, like in Saturday evening and Sunday morning, we have sessions for 2 hours. Okay, mostly 2.5 hours. Okay, so and we have some of the training member here from our, like, who have joined our program like last 1 year ago or 1.5 year ago. They have already finished the program, but still we are going to like give him updates. Okay, so here we have, like, we have the 14 candidates. It's good, like there is lots of people who is present here. Okay, so thank you for thank you to all of you to get into this like workshop. Okay, and in the last of workshop you will able to see that this structure, making the structure, designing the structure, detailing the structure, it's not very tough task. Okay, because if you play with the things, right, like we have the software, we have the codes, if you remember all the things step by step, it will become very easy. Okay, and we will also implement some of the, see, the software are very like critical part of the program, because software, if you are not using software, it's very difficult, right? So let's see. Got it? So this is our like roadmap. Okay, all of you are seeing my screen. Okay, so roadmap, this roadmap will enable you to get all the things, like first week we have introduction, like how you can solve the software problem, how you can detail the structure, how you can analyze the structure. Okay, in second week we will have the seismic analysis. See, the basic part like live load, dead load, we are not going to cover because most of you know this part. I'm right? All of you having knowledge while like for the loading, I hope so. Okay, that are very basic part. So the loading and modeling of the structure, that are not very tough task. Okay, I hope all of you know that one. If anyone don't know, please let me know, because I will provide you the video sheets. Okay, through that you can revise the concept. Because see, the in this 40-hour session, like 40-hour, mostly we are not focused on the very basics. Okay, you can count from the medium level, because our program are almost 120 plus hour basically for the structure design and analysis. So this is just the abstract of that all the things. Okay, so don't get confused that why we are not doing the basics part. Okay, because from the long term, you all of you are learning the things. Now we have to summarize that all the things. Okay, because you have to implement the things now. Got it? So here we have in week 2, you can see we have this seismic analysis. See, after the making the structure, modeling the structure, we have first thing that we have the model analysis, that is called the linear dynamics. Okay, so model analysis, after finishing the model analysis and some of the other steps, like today and tomorrow session, we will finish up that one. After that, we will enter into the seismic analysis. So basically the seismic analysis for week 2, okay, and 3, we have purely seismic analysis. It means there will be total like 3 lecture of seismic and 1 lecture of the that is 2 lecture of the wind session, that is wind simulation. Okay. Next we have for the high rise and tall structure the vibration analysis. The people who have joined our program like 1 year ago, they may have missed this base isolation damping because that time we have very basic strength. Okay. So now we have the vibration analysis, we have the collapse prevention, we have the performance based design. Okay. So one group that Mr. Manan Soni and Isan, I hope you have learned up to this seismic analysis, right?
Yes, sir.
Now
Yes, sir.
we
Yes.
have lots of things that you will learn, but I hope in coming week you will cover that one. So in next workshop you will able to understand the things. Okay, it's not an like big deal. After that we have the wind engineering. See, lots of people having the wind engineering. Like 90% people get stuck here. See, this topic, the wind engineering, and there are also the time history method. Okay, especially the time history method in non-linear. Okay, it's very important topic that we have to focus like on better way, and also the wind simulation. Wind simulation, it means we have wind analysis that you can perform with the that coefficient factor and gust factor. We have the wind tunnel test, and there is one software that I will remind you, that Rwind. I will send all of you to install this software procedure with the video. Okay. So first thing that you should clear in your mind, that combining all your concept that you have learned, you have to combine in this session. Okay. And Mr. Kareem and I will take all of your this that what you can say, that workshop. Okay. So in week 4, we have checks on structure. So what is this checks? If you see that checks means, whenever, just take an example, you are going to a doctor for any kind of medical issue, then doctor will prescribe you medicines. Okay, and also they will give you some of the, they will, he will tell you to go for the blood test and different kind of like test. Okay, so just like that we have the test on structure. Okay, because how you can say that this structure is stable or this structure are going to perform in wind that for the long time, and there is lots of complexity. Okay, so to solve that issue we have the checks on the structure. After that, see, up to the fourth week, you can say you will able to summarize your all structure concept. Okay. Now entering into the 5th week, we have some of the advanced part that is called the Diagrid structure. Okay, and we have just so in the 5th week we have this Diagrid structure, learning Diagrid structure with analysis and design. So basically, see, if you see the Diagrid structure, I will elaborate in our coming session or in coming hour. So here, if you see the Diagrid, learning the Diagrid structure, from here you can count this one as a composite structure. Okay, composite structure means now we are going to use the steel also in the structure, and you need to update yourself with some of the extra software that is called the SAP 2000. Okay, and the there is TEKLA structure and RAM connection. Okay, this is very new thing for the people who are in the RCC part, but don't worry. Okay, first finish the RCC, then get into the steel. So we will implement this all the things from here, week 5th. In outrigger system also we will implement. In tube system it may be or it may be not. Got it? After that we have see this Diagrid structure, outrigger and tube structure. These are the part of, you can say, the composite type of structure. Okay. After that we have twin tower case study. Like we will do some of the case study on some structure that are like, you may refer to the world iconic structure that are made in all over the world. Okay, there are lots of structure that are twin in nature. Like there is two tower system. Got it? That is very important because as you will see the shape of the structure that are going to govern the performance of the structure as well. Okay. Now in the 6th week we will see the commercial tower, that is G plus 52. Okay. And see this all the structure I am writing here, G plus 52, that all the structure you will get this all the things in ready-made mode. Okay, you need to study these things. You don't need to make the structure. Okay, you need to study. But if you make the structure by your own, it will become very informative. Okay, for you. The 7th week we have detailing of the structure. That detailing part we will do the some of the design drawing sheets. Okay, we will extract and we will also implement here some of the like beam tool. Okay, and after that we have the proof checking. Okay, and in review, and in the last we will have the certificate distribution. Got it? So this is our roadmap for this like program. Okay, the workshop. So let's see the today's session, that what we are going to do today. Okay, just wait. So I hope all of you are getting my point.
Yes, sir.
Yes, sir.
Okay, fine. And see the people who have joined session today, please remind that don't miss any session, because if you if you didn't practice so much in your previous batches, okay, this workshop will enable you to revise that all the things in short term. Okay, just in 2 months, right? So here we have the today and tomorrow topic. There may be some of the topic we will take tomorrow. Okay, like here we have, see, list of analysis checks. Okay, the list of that codes, substructure analysis design, like structure element. This is the structure element. As you know that we are designing the moment frame. In moment frame, we have some of the things like slab, staircase, lift, truss that we will use in the outrigger, diagrid, dampers. These are some of the you can say the extra member in the building system. Okay, after that we will see that how we can collaborate the things between ETABS to the TEKLA structure, collaboration between SAP 2010 RAM connection, ETABS safe and CSI detailer. Why we need to do this one? Because see, there is lots of software nowadays, and you don't have to confuse that which software when we have to use. Okay, as you know that if you are using the ETAB, then it's very convenient to use the SAP. Okay, also the RAM connection are little bit different. RAM connection and TEKLA structure. This software demand, like it's basically for the steel structure. But in TEKLA structure, you can do the RCC detailing and their estimations very easily. Okay, that's why we are going to introduce the TEKLA structure. We have safe and CSI detailer. In tomorrow session, we will see one complete project with all type of analysis, design, checks, their substructures, okay, and their report. Tomorrow we will cover up this one. Okay, we will try to cover this one. If any topic left, we will cover tomorrow. So I hope this this week what we are going to learn, it's clear to all of you. I'm right? Hello.
Yes.
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 Yes, sir.
Okay.
Yes, sir.
So now let's see that first thing that we will do. I hope all of you know the list of analysis and checks. Okay, but we will revise that one, that what kind of analysis, what kind of checks we have, because every time you are opening the structure, any structure, see there is lots of check and analysis. Every time you don't need to implement that one, but whenever you will go rise to earth, it means like see, it's just an prediction, or just an, you can say, not prediction, sorry for that. We have some of, like if you have G plus 3, okay, then if you are going to implement all the seismic analysis forces here, then the design demand of the column and the beam are going to increase. So, okay, and the structure become uneconomical. But the same thing, if you go for G plus 15, there is more type of analysis and design are going to introduce. Okay, and checks. If you again go for G plus 40, again some of the things going to change. Okay, so these are the your engineering skill sets. You need to decide that which analysis are going to introduce at which path. If you are not getting the satisfactory result, then you have to implement, like you have to change in their structure, their shapes, their geometry, their analysis. Okay, sometimes you have to take the reference of national and international codes. Like currently, if you are studying, you know that IS code are not very well for the high rise and tall structure. Okay, because high rise and tall structure, it's purely, you can say, this is all based on the like performance based design. Okay, in the PVD part, like whenever you are learning, it means basically you are applying the non-linear method, okay, in the static and dynamic, both cases. So these are some of the extra things that you will learn here. And also the data implementation, like you are saying, applying data into the software, this is very important. Okay, if you know how you can implement the data, I think the ETAB is just an calculator. This calculator, you have to implement the things, like if you are just implementing EQX, earthquake in X, earthquake in Y. Okay, so what you will get against that one? You will get the, yeah, what type of response you will get in graphical form, that is story displacement, right? Their maximum, what is the maximum displacement of the top roof? Okay, so this kind of thing you can like abstract from here. Got it? So now let's come to the our point, the main point, the list of analysis. Okay, so what kind of analysis and what kind of design we are going to implement? Okay, so just see. And see, the there is the like most of you have got the presentations. Okay, you can download the presentation, I will provide you. See, and each after each workshop, all of you will get one email, okay, regarding what we have learned with their video sessions. Okay, so you can revise again. So the first thing, that list of analysis, right? So let's see. So this is some of the like analysis that we are going to cover. All of you know this analysis very well, but you can again revise that one. So linear static earthquake analysis, non-linear static analysis, construction sequence, pushover, geometrical non-linear analysis, P delta, buckling analysis, material non-linearity analysis. These are all the like if we have geometrical non-linearity, then we have these two part. Okay, material non-linearity, got it? Linear dynamic analysis and wind analysis. And here we have, that is called wind tunnel test. Wind tunnel test. This is very interesting. This topic is very interesting. Got it? So this is analysis for that, for the
Hello.
our, yeah.
Sir, are you doing axial column shortening analysis also?
Yeah, can you repeat, sir?
No, no. Will you elaborate in the detailed classes? Will you elaborate this axial column shortening analysis also, na?
Yes, all see this is the overview. Okay, because today
Okay,
is
okay,
our
okay.
first session.
Okay,
Okay,
sir. Okay,
in
sir.
our coming lecture, we will cover this all. So elaboration of that all the topic. Okay, we will do, but not in from very basics because we understand that most of you have like you are learning from like last like 5 to 6 months or 8 months or 10 months. Okay, apart from that, we have the codes. Okay, so the codes, to referring the codes, why it's important, you will see basically AC code, okay, 716, this highest code for the loading and the earthquake and seismic analysis. First, you have to learn the highest code, then you have to focus on the international codes. Okay, so this code you must have. I hope all of you having this code. If you don't have the code, you can search on the internet or you can find in the drive also. Okay, so this is for the high rise and that tall structure that we are doing in India as per the IS codal provisions. Okay, now after that, uh, that superstructure. This is for the superstructure, right? All of you know that how you can prepare the center line. I hope so, and how you can make the grids in the ETABS software that are very like easy things. Now you are going to do that one for the complex model. We have learned the things for the basics type of model that we have similar story structure. But if you practice for like different type of story structure, it will become good. Okay. So after this one, uh, list of analysis for the superstructure. I hope all of you have understand. Is anyone having any like question from that like list of analysis and checks? No. Okay. And fine. Now let's see for the things for the that substructure. Here we have see the software you are going to use the CSI shape. Okay, many people are doing the things with the Excel sheet also for the foundation and that slab, or you can say that uh, the things that you are not designing in the ETABS, you have to adopt the CSI shape. Okay. Also, you can use the Excel sheet. We have the Excel sheet. The problem with the Excel sheet is it's very, you can say, the calculative. Okay, that's why I will recommend you to use the like software. Okay, because software will give you automated result and it will become easy for you to understand. But if you want to practice with the Excel sheet, okay, we will provide you the Excel sheet also. All the Excel sheet is ready for the localized design like beam, column, slab. Okay, so here if you see that you are seeing the presentation. Got it? This type of slab like waffle slab, the rib slab, the flat slab, okay, solid slab, checks, what kind of checks we have. Got it? So this will become our like integral part. Tomorrow we will apply this all the things like from superstructure to substructure. Got it? In single structure we will apply, we will extract all the sheets and complete report on the project. Got it? Now if you see that uh, after this footing, we have some of the more advanced topic. Okay, like you may know that one that is called the vibration analysis. Okay, so why we do the vibration analysis? So basically, the purpose of that one, like every structure have tendency to vibrate. Okay, in their nature of in their self weight or with exposed to the lateral load also it will vibrate. So the vibration analysis is very important and controlling the vibration is also important part, right? So how you can control the vibration? So we have some of the specific topics for that one. Like if you see uh, here, So here you are seeing that for the vibration analysis and that kind of thing, not this not this one. Just I'm sharing you the other one. And for that PDF, you can refer to the group. Here you can see that this one, yeah, this one. The base isolation dampers, twin mass dampers, okay, and there will be the other technical things will be okay. So how you can control the vibration in one of our batch, like in high rise and tall structure, we have learned about this base isolation dampers. Twin mass are not taken till now, but it will be taken in the workshop. Okay, so this is the vibration control and vibration analysis, and you need to study about their like how you can control the vibration with the mechanical equipments. Okay, what is the mechanical equipment? Like you can provide the bearing. Okay, bearing in the like base of the structure, like where our foundation, like here we have the column arrangement, and here we have the substructure. So you can separate the footing and the column with bearing. So this is the mechanical. This is mechanical design, and also the dampers. If you are controlling the vibration, again you can use the dampers. So design of the dampers or tune mass. Tuned mass. You know what is this tuned mass? Tuned mass means like if you have this structure, okay, and you need to control the vibration, you can like put some of the masses, okay, that are here. Also, you can put the like some kind of water tank that are generally nowadays it's used as a swimming pool, okay, to control that kind of vibrations. So let's see that I will open some of the presentation that relate with the most interesting topic, okay, because everything you know very well. We will just discuss major things, okay. So let's see what is this. So why we are very focused on the earthquake? Because see, the earthquake analysis are like little bit typical. Typical means in the sense if you are going to design the structure, most of the things are like surrounded by this earthquake. Okay, so here you are seeing that, and one thing that always keep in mind, we can design earthquake structure that structure can resist the forces. Okay, not 100% earthquake proof structure. You can't design the 100% earthquake proof structure because in but see, if you change the framing and if you do the like research over that, it may be in the coming year. If we have new technology to do that one, we can do. But right now, we can just make the structure that are earthquake resistance. Okay, so here you are seeing that flexible foundation. So this is the mechanical equipment, right? Here you are seeing this one. Okay, so what is there? Like their drawings, their 3D models. Okay, we will design that all the things, right? In the some using the software also, because this you may didn't you have learned these things. Okay, how you can design this one. After that, uh, we have not this one. Yeah, this we have the dampers. This is also the mechanical damper. Okay, you are seeing the piston, you are seeing the braces. Okay, so how you can design this one? This is some of the extra part. Then we have the pendulum. Okay, you can insert this one to control the vibration of the structure. Got it? So these are the realistic approach. Okay, you may not, like after getting one level, like if you know the structure very well with all analysis and design procedure, then only you can implement this one. Without knowing the previous procedure, you will not able to implement this type of structure configuration. Got it? And this one we have shielded building from vibration, that are the next we have the reinforced the structure. Okay, like here you can read, to withstand the collapse, building need to redistribute the forces. Okay, so this is the way that you can. We have the shear wall. Okay, the diaphragm. Okay, these are the types of the equipment and the method that you can implement here. Got it? If I talk about the base isolated, okay, so let's see the about the base isolated. So you can see this is our base isolated. Okay, here you can see, got it, and how it's going to like save our structure from the earthquake that are there. Briefing. This is the briefing. Got it? In ancient, not this one is the, I think this is the newly made. You can see this is some of the history of seismic isolation. Like you can see that it's also used from our very like ancient ages also. Got it? So that's why we need to implement. Got it? Next, we will see that this wind type of thing, that the things from the wind. Okay, we have discussed about the earthquake. Okay, now we will discuss about the wind, and later we will discuss about our other framing type. Just I am opening some presentation. Wait. See, if you see the wind part of any structure analysis and the design procedure, so wind engineering is very different department. Okay, in India, basically, it's not very like adaptable things, because whenever you are designing the structure at the onshore structure, okay, like on the seaside area, then it's very exposure to the wind, and wind analysis are very important. Not only the wind analysis, their real time simulation is also important. So that's why we need to introduce the wind simulation, and how you can do. See, in India we have not so much facility to test that one, because it's required lots of equipment. Okay, like Hindustan Aeronautical Limited, that in India, the only one company who have the wind tunnel test. But we don't need to worry about that one, because now we have the software. Okay, so with the help of software and with the help of calculations, basically we will able to do that one, right? So what is that one? So you know that whenever any cities or any structure or anything that are like uh, understanding against that the wind pressure or wind load, you can see this we have. Okay, so here you are seeing that this is the like 360-degree view of any structure that are present here. Got it? So you can see just. So here you can see that, like if you divide whole structure around 360 degree, then we have different angles. Okay, we can put the load there. Okay, and we can check their distribution on the real structure through our software. Hello, Karim.
Hello, good evening, sir. Hello.
Yeah. So, Karim, can you elaborate this topic about the wind tunnel test?
Sir, actually, wind tunnel test, it is a perform separate department. Okay, basically the FEA models we have prepared in our ETABS. So the department which is performing the wind tunnel. Okay, so whatever the wind
Yes.
speeds as per the course, it can consider, or as well as the options available which is dealt by the wind tunnel department, like the windrows. This one you are recently showing the picture. Okay, basically it can identify
Okay.
the wind speeds. Okay, after that
Okay.
it the models it can got it, or some frequency range it apply. Okay, or it just rotating 360 degree on the behalf of, we have defined the function load cases, movement based history. This one we are calculating the force point loads fx, fy, mz. We have need to be apply or interpret our results, sir.
Okay. So basically the wind engineering, this is a part of the wind engineering. So we need to first calculate the wind pressure and wind load. After that, we will implement into the structure and we will check the structure response. Right, Karim? So
Right.
what kind of structure response we will check from the wind tunnel test?
Sir, basically, whatever the story, whatever the geometry, as per the ASC 716, which can give some basic specification on the behalf of VR apply. Okay, which is depend upon the several factors like the vortex shadings, building shape, this one. So ASC 716 gives the criteria on the behalf of we have need to be apply the wind tunnel tester, or CTPH reports. So this gives the specification on the behalf of VR apply
Okay.
the wind tunnel tester.
Yeah, we will refer to the, this is one of the like
Yes,
wind tunnel
yes, sir.
testing for high-rise building. Okay.
Hmm.
So this is some of the guidelines that we have to follow up for the wind tunnel test, and it's very new thing. I will suggest you, all of you, to study this wind. Okay, very well, because if you see, as per the your career point of view, any consulting firm, they are like working in the international level. They have different wind engineering department. Okay, and they demand like a specific wind like wind knowledge. Okay, so we need to do that one. And where we will do, so we have like you can do in the ETAB also, right, Karim? In ETAB you
Yes.
can also perform this wind tunnel test, but we are going to use another software packages also. So basically you must need the FEA model, or FEA model either you have created in the ETAB or somewhere else, but you need that one. After that you can implement that one and you can record their responses. Okay, how their story, you can see there are lots of graphs that are given here. Okay, so I hope the wind is clear to all of you, right? Now after wind, if you see our like plan, learning plan. So after that, what we have here, that first thing that we will focus on the outrigger structure system. Not outrigger, sorry. That is the Diagrid structure system. It's very important to learn because it's very economical. If you compare the Diagrid with the conventional, we have that video on that one also, and we have done like research on that one also. So the Diagrid structure is very important, but how you can design the Diagrid, how you can obtain their parts. So this will become composite type of structure, right, Karim? So the Diagrid structure basically
Yes.
it's, you can refer to the composite because there are steel members that we have to design, their connections we have to design. Okay, so I will open one presentation to show you that one. Uh, so all of you are getting the things.
Yes, sir.
Hello. Okay.
Yes, sir.
And it's interesting or what you are expecting?
Interesting, sir.
Interesting. Okay. Okay, just wait. I am opening one presentation to show you that. And we have the software part also, but don't worry. Just after finishing this one, we will get into the software part. Okay, because software we will today we will like just elaborate that how you can collaborate with the different kind of softwares. Okay, just give me 1 minute. So here you can see this is the basic approach for the Diagrid structure. Okay, like this is our ideal arrangement for the Diagrid structure. So there is inclined member. Okay, so this is not very easy things to model in the ETAB also. Okay, you need like some of the medium to advanced level to do this one, but you can do in the other software like TEKLA or any other relevant software that are very much convenient with the steel. Okay, so okay, now uh, why we are doing this Diagrid structure, what is their benefits, okay, their elaboration. We will learn these things very in deep, okay, and also we will design their members, not only their like analysis result with their members also. So after learning this point, this one, we will get into the after that one we have the outrigger structure system. Okay, you may not have idea about that one, but this is one of the like very innovative approach to control the deflection in the structure. When we are going for the high rise and tall structure, the general challenge is the deflection in the structure, their story displacement. Got it? So to control that one, what we need some kind of a special type of arrangement in the structure. Correct? So that is called the outrigger structure system. Right? So I will just open their one picture and I will show you what is that things. This is called the outrigger truss system. Okay. Here we have, you are seeing that there is truss implementation in the structure right here and here. So this is new challenge. Like if you are making the RCC structure, how you can implement this steel one in between that. So this is very tough and very challenging. So this is outrigger truss system, but you can use. I think Karim, you can use that RCC component here also. Hello.
Sir, basically the systems we are considering in terms of walls arrangements. Okay, walls arrangements also consider, or as
Okay.
a steel also. Okay, basically
Okay.
different types of systems available, like the virtual outrigger also, offset outrigger. Okay, the types also available on the behalf of we are performing the modelings and analyze and design also, sir.
Yeah. So there is one another type of inside that one, like if we have this structure, right? So here we can implement the truss structure like that to control the deflection. Also, we can use that RCC wall here. Okay, so this is type of like you are making one belt around the structure to control the deflections. Got it? So this is also an like very good things that you will learn here. After that, learning this outrigger system, we will enter into the that is called the first. I will discuss this tube structure system. Okay, so the tube structure system, you know, generally for the super tall structure that are like G plus 10, not G plus, sorry, G plus 100 or 80 like that. Then we have to use the tube structure system. Karim, kindly open the example for the twin tower. Okay, that recently you have made. Hello.
Yes, sir.
This structure have you right now in your PC? That twin tower structure.
Once more, I will check it, sir.
Yeah. So after that one, we have this tube structure. Okay, so what is this tube structure? Let's see. There is type of tubes like tube and tube, bundle tube. Okay, so if you see that one, here we have the tube structure, that we have the outer periphery column supports. Okay, inside that we have one core, RCC core. Okay, and around that one, all the arrangement of the structure has been done. Got it? You can make this type of, see this this is, you can refer to the like world iconic structure here, right? Because this structure is made with like with response to the gravitational forces also, because their base are large. After, if you are step up, their building dimension are going to decrease, because this is a very like good thing for the what you can say that for any type of structure that are against the gravity. Okay, like dam is also made with this type of things. Like first we have the more area, less area, and less area. Got it? So this is the tube structure system that we will learn in detail. See this, we will give you the ready-made things because it will take lots of time to make that one. After that, see, after learning that one, we have this breast tube system. This all are the part. I will give you one like short example for this one. So I think all of you having clear idea about this workshop, right? Hello.
Yes, sir. Yes,
Okay.
sir.
Both the RCC and both the steel. The people who are from the steel one and RCC, both of it will benefit for the all of you. Okay. Now after that, this one, what we have the next topic for the today's session, that is the software. You can just write down as a software problem. Okay, the software type of things, that how you have to deal with the software. Okay. Yeah, Karim, did you find that twin tower? Hello.
Sir, basically, we have required to search it. We are saved it, sir.
Okay,
We'll
okay,
check.
just search that one. Okay, so first we will see. We have seen. You know these two software, that ETAB and TEKLA structure. Most of you know. Okay, I will show you that how you can collaborate between them. We have seen, if you are using the TEKLA structure, all of you having the TEKLA, that the ETAB in your PC, either ETAB 18 or 19. Hello. All of you having the ETAB
Yes,
18
sir.
or 19?
Yes, sir. Yes,
ETABS
we
having,
have.
sir.
We have.
Yes,
We have.
sir.
Okay.
Sir.
So
Not
TEKLA
TEKLA
structure. Okay, TEKLA structure you need to okay, you need to install. And I have already sent in the group, the link in the group. You can install that one, TEKLA structure, and you can collaborate between them. Okay. So just let me open the software. Okay, sorry, just give me 1 minute. Karim, hello. Meanwhile, hello. Yeah, Karim.
Hello. Yes.
Yeah, so just I'm opening the software. Karim, please explain the things between this SAP and RAM connection. Okay, like see, you are designing the things in the for the steel structure, like you have the truss structure system. How you can design after taking the design consideration, how you can do the connection design. Okay, so Karim will brief you about that one. Okay, Karim, I am allowing you to share the screen.
Okay, sir.
Please mute yourself. Hello.
Sir, my screen visible, sir. Hello.
Yeah, your screen is visible.
Basically, sir, these are the models, G+6 buildings we are prepare in the SAP 2000. Okay, so these are the wireframing basically. Okay, wireframing basically represents the members, not for the RTC. RTC part basically we have made to provide the reinforcement, but steel structures we are using the members. Which members we are using as per the code provision? So these members basically we are using as per the American standards. Okay, so basically when we performing the wireframing, which represents the members, whatever the members we are considering, after analyze and design, it means our member will become fast. Okay, we have need to design the connections also. Connections like when we take the separate joint, this one, or take
Hello.
this one joints. Hello.
Yeah, just wait. See, the Karim, like you can take the example that if you are going to design the outrigger truss system, then you need to do these things. You can do in the ETAB also, but if you use the SAP, it will give you the better result because the SAP is basically used for the infrastructure project and the steel structure. Okay, so you are seeing one perspective of the building that are from the side view. So you can see that you can just implement these things in the RCC structure too, and how you can take the that forces for the connection design. Okay, so can you please continue?
Hello.
Yes.
Sir, once we are completed the wireframing, it means our member will become fast. Okay. Okay, wireframing part. Steel part is divided in two parts: wireframing and second part connection. Wireframing, whatever the loads, whatever the framing, basically we are controlled. But how can we connecting the joint, one joint to second joint, as we call it the connection? Depends upon the type of loading. Particular joints we have to consider what is the major shear, minor shear. Okay, these values we have need to be taken from our model. Okay, suppose when we move for this one or identify the moments, this one, or the moments can be considered and apply this one. Okay, so whatever the particular joint when we consider, basically the models in the what we call as a we have need to graphics just turn off display and deform shapes. Okay, so when we designing the connection, we have need to prepare one joint. So open the RAM connections. We are moving for the joint. Which type of joints we are consider? Okay, so different types of joints available like BCF, BCW. So options available. First of all, performing the framing connection or truss connection. Two options available. I want to perform the framing connection. Which type of joints we have need to consider? BCF, BCW, BG, BS, CS, this one, which represents the beam column flange, beam column web, beam girder, beam splice, column splice. Okay, we have need to be performing the connection modeling, not for the wireframing. Okay, not for the modeling perform all over the framing, just performing the connection joint modeling. So we are selecting the particular joint. When we selecting the particular joints, we have need to provide the templates also. Which templates we have need to be considered? On the behalf of, we are put up the V2, XZL, M33, all the parameters we have need to be considered, depends upon the templates also. So first of all, we have need to provide the connection modeling. So the joints, which is the BCF, you are required to opposite beam, yes or no, column continue or no. Okay, define the members. Your members will become the beam, prismatic, tapered, hunch. Which is the type? What is the profile? Profiles indicates the what is the which course you have need to be taken on the behalf of define the section size. So section size may be W shape or HSS, channels, angles. Okay, we have need to be selecting. So these section size we have need to be considered as per our wireframing order. Okay, define the grade also, which grades we have to be considered. Skew angle. Sometime what will happen in the plan, our beam will become skew. Some angles also we have need to put up the skew angle also. Finally, we can see that we have need to put up the connection modeling. Okay, or clearance. Generally consider the half-inch clearance between two members is one, or what is the length of the member. Okay, or if you want to consider lateral tolerance restraint, you can also consider. These are the modeling for the beam related to this one beam. Then define the column, basically joint for the BCF, beam, column, flange, this one. Similarly, members, prismatic, sections, W shapes, grade, orientation, when we consider this one as per our model. Okay, so when we selecting this one or performing okay, so you can see that on the behalf of parameters, when we put up, your joint will become generated. It means the joint for beam, column, flange, BCF along the flange. So members, basically we are using the HSS. First of all, we have to create the joint using the HSS options. Okay, so moving for again, or right click this one, the options available load. Okay, we have need to put up the load also. So depends upon the in the models, when we identify the how much amount of V2, axial, M3, we have need to be considered. So when we come to our model parts or moving for general options, standard, apply and okay. Okay, so any particular joint, suppose we have need to be considered moving for the 3D, or suppose I am just selecting the joint for beam to beam or beam to column, this one. Suppose we are selecting this one joints, or this joints we are selecting this one. Right click, show selection only. These particular joints we are considering along the BCF this one. Okay, or when we identify the particular forces on a particular connections, we have need to be identified.
Hello. Yeah, Karim. Hello.
Yes.
Your voice
So
is lacking.
now,
Okay.
okay, sir.
So basically, yeah, just wait. Basically, like you need to improve your knowledge in this type of software also. Okay, because as a structure engineer, you need steel RCC very well. Okay, so you have to adopt that one for implementation of like things in the RCC structure too. Okay, so this is one of the different part as major people here from the RCC. So you may find the difficulty, but don't worry, we will try to solve your problem after after the collaboration between this SAP and this RAM connection. Okay, we will able to design our truss structure. We will able to design our outrigger system. Okay, that all kind of thing, right? The second thing, just stop sharing screen, Karim. Now you can see that software collaboration. So if we have, see, if we have ETABS model, okay, that is the FEA model. So this ETAB model, you can export to the different type of software. For detailing, you can use the CSI detailer. Okay, but CSI detailer, as you know, that you may need to like do the some of the changes. Okay, and the automated generated sheet are not so much like preferred in this industry. So we need some kind of extra tool, like to solve that problem. You can import that model to the TEKLA structure. Okay, and you can take the reference of CSI detailer. You have to make the model in the TEKLA, and after that you can do the detailing very easily. Detailing plus estimation. Okay, how you can do? I will show you that what is the need of that software. So right now, Karim, show any sheets with the that generated with the CSI detailer. with
Okay,
help
sir.
of
I will open
ETABS.
it, sir. Yes,
Okay, so
yes.
Karim will show you one example, and I will just tell you that how you can implement the things just right in the TEKLA structure. Okay, for the better performance. Got it?
Hello, sir. My screen visible? Hello.
Yes.
Sir, basically, the EDB files we have got from the ETABS, we have need to be performing the detailing. Okay. So CSI detailers we are using on the behalf of, we are extract the sheets also, whatever the plans, using some CAD also, performing some drafting also determining the schedule also. These are the typical floor plans. Sorry, the foundation level, this one indicates the type of footing also. Typical cross section indicates this one. Okay, or gives the reinforcement schedule also, this one, sir. Okay, so basically we are using the CSI detailers or using the CAD also on the behalf of, we are extract the sheets also. These are the foundation plan, this one, or we can see it is the second floor, this one, which represents the type of framing, this one. It is the slab also represent this one. On the behalf of, it can give the reinforcement schedule also, schedule typical sections also, this one. Okay, basically we are showing this one. I have one models also. These are the models which is in the ETABS. Okay, G+4 model, this one, sir. Okay, so when we export in the CSI detailer or using the CAD also to performing the sheets, this one. Okay, so these are the sheets for the second floor, this one, or first floor, this one also. Okay, or beams also, this one. These all the sheets we are extract this one. On the behalf of, we are performing the fabrication as well as performing the execution work, this one. Okay, so third floor also available, this one. Okay, or the roof slab also available, sir. Okay, so finally we are got the sheets, this one. Okay, so sheets available to performing the fabrication or execution work with the help of decided detailer or the software we are using, but using the CAD also to performing some drafting work also, sir.
Okay. So, so all of you get the point that how you can utilize that software. But see, uh, this Karim, this is the adject sheet that you have created from the CSI detailer.
Yes, sir. We are creating the CSI detailers. Okay, but sir, we are using the CSI detailers or export in the EDB. We have got the remarkage also, or got the what we call as a major things also we have got. But we are using the EDB file to export, sir, which takes some time taken, sir.
Okay.
Finally,
So,
these are the final sheets, sir.
got it. So now we will. You can see there is one software that are, you know that one. We have that called the TEKLA structure. Okay, people know very well here in this group. So the TEKLA structure is also you can utilize for detailing the structure. Okay, you can extract that all the sheets and all the facilities that are available here. And I will personally recommend you to use this software. If you use this software, your like after the designing and analysis, your like most of the problem that you may find for final presentation of the project, you can solve with the software. Okay, so you can arrange all the drawing sheets, you can make the 3D model again for the presentation, because see, the ETAB file while presenting and modeling, it's not very preferred. Okay, because that are just the line diagram. If you see the ETAB, you can just see the line diagram. There is no such kind of major physical model you can find there. Okay, so like here we have one software that is called the TEKLA structure. Okay, you might have seen this one on the internet, or you may have learned from us also. So here just take an example. I have all the drawing and modeling sheets, okay, that we have. Now if I want to make some kind of detailing sheets here, like I am making one short model. Okay, so next what we need to reinforce this one. Okay, so in the TEKLA structure, if you see, their reinforcement are very like you can do the reinforcement very quickly. Got it? Like here we have the column reinforcement. But see, this seems to be very easy, but sometimes you need to modify that one also. Okay, like we know that how much reinforcement we need, what will be their layout. If you know that one, you can simply arrange that all the things. Like if you see the column layout, their lapping strips, you can arrange that all the things. After making this one, just take an example. We need to extract the seeds from here. Okay, this is take an example of column. If I need to extract the seed, it's very easy, and you can do the what you can say that you can extract that how much material and their cost unit weight, that all kind of thing. Okay, so now let's see. I'm just selecting this one, and this all we will do in our session. We will do that one. Okay. So you can see that just wait, this is not that one. Yeah, Mr. Ombi, please switch off your camera. Okay, just give me 1 minute. I am trying to show you with another. I think there might be some issue in the software. Just wait. I am extracting the single one. Just wait. This is not working here. Sometimes see, sometimes this may not available. But just give me 1 minute. Give me 1 minute. I am connecting with another PC. Okay. And see, whenever you are joining the session, okay, please attend up to last, because if you just skip the last part, okay, it's not good thing. Just wait. I'm connecting. Tomorrow also we have session. Please remember that one. And today we have just a informative session. But from tomorrow we will operate all the things. Okay, like we will do all the analysis, design, that all kind of things. Okay, so please present tomorrow also at morning hour. Okay, at 8:30 a.m. Yeah, just give me a minute. So meanwhile, if you have any question, you can ask. Hello, anyone having any question? Yeah, just opening one software. Yeah, Mr. Nee, please. So the drawing sheet, whenever we are extracting the drawings, okay, drawing sheets, there might be some issue while making that one. So to solve that issue, we can generate the automated result from the TEKLA structure. Okay, and TEKLA structure is not only used for the steel RCC one. There is lots of like other things there that you may able to perform. Okay, so I think there is people in this group who have learned the TEKLA structure. They might have the knowledge in the software. Okay, just give me 1 minute. Software is taking time to open. Just in 1 or 2 minutes, it will open. Yeah, now it's okay. So all of you know the IFSC file, IFC file. Hello. Yeah,
Sir, yes, sir.
yeah. So IFC file you can export import model to this software to another software. But the problem with that one, uh, that you can't edit that one. Okay, so it's better to make the model in different software when you are using the different software. Okay, the collaboration between software. See, if you have that ETABS file, you can directly export to the TEKLA. Okay, but there are some of the error you may find. So it's recommended to take the reference of one file or DWG file, and you can make the model in the 3D BIM software. And making the model in the BIM software, it's quite easy. It's very easy. Okay, once you make the model, it's also good for the presentation. I will show you how you can. Just you have seen that I have made one structure unit with the RCC column. How it's easy. Okay, but if you go in the another software like that, you may have the ETABS or SAP, it take more time. Okay, and also there is error. But in 3D software, there are no such kind of error. Okay, so let's see. Yeah, my screen is visual. Hello. Yes, now it's okay. So here you can see this is the interface of the TEKLA structure. I will just tell you that how it's good. Okay, like I'm just making one column arrangement here. Like generally we have column, beam, shear wall, this type of arrangement. And I'm putting some beam here. Okay, just avoid the some of the error because we don't have time right now. Okay, I'm just making one reference one. So here after making this one, just take an example. This is one unit we have. We need to reinforce the thing. Okay, so if you see the concrete, okay, concrete detailing here, we have the column reinforcement layouts. Okay, you can implement that reinforcement direct from there, but it's ultimately you can change their units also. Like if you need more bar, more type of like that rebar details, okay, longitudinal bar, primary type, everything you can do here. Got it? After that one, Okay. Yeah. Okay. So here you can see that we have this automated reinforcement for one section. We can just implement that one for all the sections also here. Okay, like if I want to put the reinforcement layout here, here, and here. And what's about the beam? So beam section also you can reinforce. Okay, you have to choose that one, the beam layout, but you can change their strips also. Okay, strips of their dimensions, each and everything you can change. Okay. Like here, I have reinforced this all the sections. Now let's see that if we need to abstract the detailing sheets from this drawing units, we just need some of the tools to apply that one. Okay, drawings and sheets. Okay, after that, we need to create the drawings. Here you can see that we have different type of drawings. Okay, I'm creating one cast unit drawings. Okay, and you can see the drawings has been created. If I check the document manager here, you can easily find that drawing sheets. Okay, it's opening. Here you can see it will give you the automated reinforcement for this beam. You are seeing that one. So this is the power of this software. Okay. Also see, not only the drawing sheets, you can extract another part that is called the that cast unit weight. There, you can do estimation very easily. Like if I want to do the estimation, okay. Here we have create from selected. Okay. Now let's see that if I want to make one cast unit bill of material, like how much like quantity you are using. Okay. So you can see that you will directly get this one, like unit B1. Okay. What type of reinforcement you are using, their grade of concrete. Okay. That all kind of thing. You are seeing the undefined because we don't have defined the bar welding schedule for that one. Okay. So this is the like things you can do with the TEKLA structure. Cast unit list also you can create. Okay. So this all. After that you can also get the material summary list. Here you can see the material report. You can abstract. Correct. Each and everything you can do. Not, but see the things is you need to learn the software. It will not take so much time. 10 hours of this like software is enough. Also, you can do the class detection. There is lots of things that you can perform here. There we have A&D model. Okay, if you are using the TEKLA structure, you need to like install some plugins. So here you will able to see the ETABS. Okay, here you will able to see very easily the ETAB things. After that, you can directly export that from the ETABs here. Now, Kareem have just tell you that how you can extract the sheet from the ETAB to CSI detailer. But here you can make the physical model and you can again extract the things. But here you can extract the all the required things that are in the building structure. Either it's a staircase, either it's footing, either it's beam, either it's column, shear wall, core wall, anything. Either it's tuned mass type of thing. Like if you just assume that we have the steel like ball or steel type of things in the structure. Okay, then how you can extract that one? So very easily you can do. Got it? So this is one of the very powerful tool that nowadays very popular in the structure field. Okay. So I hope this session is like very informative for all of you, right? So anyone having any question from today's session, they can ask. All of you get my point, get our point that how you have to operate this workshop.
Yes, sir. Only we can see the real things on using the software, then only we can able to understand.
Yes. See, software, different type of software. Yeah, Mr. Nikanju, your voice is breaking. Okay, Mr. Nikanju, you can type your question because your voice is breaking. Okay, fine. So all of you please remember, tomorrow we will have the session. Okay, at 8:30 p.m. 8:30 a.m. Sorry, tomorrow we will have session at 8:30 a.m. Kindly present because tomorrow we will do one whole project. Whole project means we will start not the low rise structure. Generally, it will be the high rise. One complete project we will do tomorrow. Okay, so it will revise your all the concept that you have learned till now. Here you are seeing that tomorrow topic. This one. Okay, like software, we will do all the things in the ETABS for from basic to very advanced, and we will also show you that how you can put the data. Okay, superstructure, substructure, then analysis, and all results with their DBR. That is called design based report. Okay, and ETABS report generation. This all will be our tomorrow topic. So tomorrow is very informative. Please present. Okay. So thank you very much for attending the session. Okay. Have a good. Okay. Good night.